In this video, we have to find the sufficient statistics for estimating lambda. The PDF given is an exponential distribution, but we have to find the sufficient statistics for estimating lambda. Solution. For more on this topic, you need to subscribe to this channel. In finding the sufficient statistics for estimating lambda from the exponential distribution, we use the factorization theorem, because the factorization theorem is most times used to find the sufficient statistics for estimating parameters. And for the factorization theorem, it states that a statistics is said to be sufficient if it can be factored out into two components. This time we have lambda. This is the first component, x1, x2 to xn. It depends on lambda, the first one, while the second one does not depend on lambda. So this is what the factorization theorem states, that a statistics is said to be sufficient if it can be factored out into two components. This is the first component, and this is the second component. Of course, this does not depend on lambda. Of course, this depends on lambda, and this does not depend on lambda. Now, we are given the PDF to be equal to lambda exponential negative lambda x. What do we do next? The first thing to do is to take the likelihood function or the product sum. So we'll take the product sum. If you are taking the product sum, it becomes the product sum for the given PDF can be written as this: lambda exponential negative lambda x. So what is the purpose of this symbol here? This symbol will enable us spread out the PDF that is given, so that we can be able to factor out the PDF. So when we factor out the PDF into two components, then we can be sure to get our sufficient statistics. Of course, the product sum for this function means the first one, negative lambda x1 multiplied by lambda exponential negative lambda x2 multiplied by, it goes on, lambda exponential negative lambda xi. So it then means that our function, if we take the product sum, we'll get something like this: lambda exponential negative lambda summation of xi's. Because if we sum this one, if we sum it n times, we get summation of xi's. So the next thing to do is to compare it with the factorization theorem. So by comparing with this is lambda into u x1 x2 to xn, which depends on lambda as well, x1 x2 xn. So by comparing the whole of this with this, we can now see if lambda can be used, or if lambda can be estimated for sufficiency. Now, we move over to this side to write it out properly. For more on this topic, you need to subscribe to this channel. Of course, if our function is this, comparing it with this, we have f of x lambda to be equal to lambda exponential negative lambda summation of xi as I running from 1 to n multiplied by 1. The reason is because the whole of this function will always depend on lambda. We cannot separate them. So this, of course, is one of the components, and this is another component. So we can write these components as pi lambda to be mu x1, x2, xn, which also depend on lambda h into x1, x2, xn, which also can be written as summation of xi, which depends on lambda, multiplied by h1, is multiplication, x2 to xn. So this depends on this, while the whole of this depends on this. So we can say that our mean is a sufficient statistics for estimating lambda. So this is how we can estimate lambda when we are asked to find the sufficient statistics. This is how lambda can be estimated for the exponential distribution. For more on this topic, you need to subscribe to this channel.